Namaste to JVM, my dear students. Myself, Dr. Priya Gothwal, Faculty of FEM, Department of Chemistry. Today, I'm going to discuss aromatic compounds like benzene, its physical, chemical, and general method of the preparations. Okay, the aromatic compounds. The term means aromatic. Aromatic means which is a Greek word which is derivative from the aroma. Aroma means smell, a good smell. So, in this kind of category, the general introduction of the benzene, it is the first invented compound of the aromatic category, like benzene and its alkyl substituted homologous are known as aromatic hydrocarbons or arenes, which is also known as arenes or phenyl. The general formula of aromatic compound is CnH2n minus 6. As we know, as we see here some examples of the aromatic benzene, like benzene, including three double bonds, which is known as a alternating double bond, having a resonance, which is known as benzene. Okay, the substituted structure of the benzene having an alkyl substitute upon it, which is known as toluene. This substituent is known as a methyl. Methyl substituted benzene is known as a toluene. Some other example of this category, which is the CH2CH3 group, is known as ethyl, which is substitute on the benzene, which is known as ethyl benzene. Furthermore, example in this category like orthoxylene, two adjacent methyl group at the benzene ring, located at the benzene ring, which is known as xylene, and some cyclopropyl benzene. This ring is known as cyclopropyl ring. It is a cyclic structure, aliphatic structure, which is located at the benzene ring, which is known as cyclopropyl benzene. And the next is vinyl benzene. The CH2 double bond CH moiety is known as vinyl moiety, vinyl radical, which is carry on benzene ring to know vinyl benzene. In this, we get some introductory, and we have need to nomenclate the organic compound. First of all, the root word for benzene derivative is benzene in both IUPAC and formal name. When only one substituent is attached to benzene, if only one substituent is attached to benzene, here like, which is the ethyl group, which is known as ethyl benzene. The one substituent chloro group, which is related to the halogen family, the halogenated benzene, which is known as chlorobenzene. So, some special name to monosubstituted benzene. Likewise, CH3. CH3 is a methyl substituent present on the benzene ring, which is known as toluene. Some other examples of the other functional groups which is added to this, when two similar substituents attached to the benzene ring, which is meta dinitrobenzene. This position first, second, third to the nitro group is known as a meta position, or third position of the benzene, which is denoted by the meta directing. We know that the nitro group is a meta directing always. So this kind of category is known as a meta dinitrobenzene. When two dissimilar substituents attached, when two dissimilar substituents attached to the benzene ring, so firstly chloro and bromo group attached to the benzene. So we know that the alphabetically come first So here orthobromobenzene orthobromochlorobenzene. The name is given according to the alphabetically nomenclature system of the IUPAC name. Now we have some preparation of aromatic hydrocarbons like Friedel-Crafts alkylation. These are some most important named reactions including all Friedel-Crafts alkylation, Wurtz-Fittig reaction, reduction of acyl benzenes, and hydrogenation of alkyl benzenes. These some reactions to, to prepare some aromatic compounds or aromatic or benzene derivatives through this. First of all, we discuss Friedel-Crafts alkylation. This is a named reaction. In this reaction, the benzene ring is converted into a toluene, means the alkyl group present after the reaction on the product. In this reaction, when benzene is react with methyl chloride or chloromethane in the presence of aluminum chloride, which is known as a Lewis acid, to get a toluene along with a moles of hydrochloric acid. So we see in this reaction that the methyl chloromethyl is splitted, okay, is splitted into two radicals like CH3 and Cl minus. CH3 group is a methyl radical or carbocation which is known as a carbocation family initially indicated by the which is located at the position of the benzene ring to form a alkyl benzene which is known as toluene. This is known as a alkylation of the aromatic alkenes. The mechanism of this respected alkylation in two steps. Step first, formation of free radicals during the course of the reactions as we know. In this kind, C6H5Br, which is known as bromobenzene, react with sodium, which is the active alkali metal, to form benzyl free radical along with a sodium bromide salt. This methyl bromide react with the sodium to give a methyl free radical along with a sodium bromide. In step first, generated some methyl or benzyl free radicals. In second step, carbon-carbon coupling of free radicals. Second step is a coupling reaction step. In this, the benzene and the methyl free radicals combine to form a toluene, which is a product of alkylation. Next, if the two phenyl free radicals combine to form a dimer product, which is known as a diphenyl. Two benzene rings join together with a bridge, which is known as diphenyl. Okay, next procedure is when two methyl groups are combined to form ethane. This is a whole procedure of the alkylation. This is the formation, this is the mechanism for the formation of the alkyl compound, which is known as an aromatic derivative of the benzene. Next is reduction of acyl benzene. Acyl benzene is denoted by the C6H5COR group on benzene ring. So COR group is known as acyl group. This group is reduced through the active reducing agent which is known as zinc amalgam. Okay, so it is converted into a carbon containing which is known as a hydrocarbon containing compounds. So in this kind of reaction, when the acyl benzene react with the zinc amalgam, which is ZnHgHCl in presence of hydrazine in a alkali medium to form a substituted benzene which is known as alkyl benzene. Here we see that here also alkylation is brought from this acylation. So this reaction is known as acylation, acyl benzenes, reduction of acyl benzenes. Next reaction is hydrogenation of alkyl alkenyl benzenes. Here we can see the alkenyl benzene is reduced with the nickel in presence of hydrogenation. So this process is known as a catalytic hydrogenation process because in this reduction process we need uh, the nickel and need a catalyst to convert this double bond into a single bond. So this hydrogenation takes place during the course of the reaction to get a substituted alkyl derivative of the aromatic benzene. So we can see some name reactions are important and how can we convert a double bond to a single bond, okay, and C double bond to the CH2 bond, okay. So some other properties of the aromatic compounds which is known as a physical properties. In this regard, alkyl benzenes are all colorless liquids with a characteristic odor lighter than water. It is a non-polar, miscible with non-polar solvents like petroleum ether, carbon tetrachloride, etc. Melting point and boiling point show the usual regular gradation according to the branched or unbranched, inflammable and burns with the sooty flame. So these are some physical properties of the aromatic benzene, which is known as the substituted aromatic benzene. Now we discuss some general characteristics of the aromatic benzene, which is a general formula of CnH2n minus 2 we got from the above slide, okay. Some of reactions like electrophilic aromatic substitution reactions. We know the benzene show most of electrophilic aromatic substitution reactions because of its stability, resonating power. Okay, so in this regard, first reaction is halogenation reaction. In this process, the halogenated compound is formed during the course of the reaction. It is a main product which is through the many kind of halogens like chlorine, bromine, iodine, etc. So here we can see that the benzene when react with the chlorine in presence of the catalyst, like a perchloride catalyst. By the use of this catalyst, it is a selective process. If we not use the catalyst, the chlorination is further not stopped on this kind. So we get a chlorobenzene during the course of the reaction. The mechanism of the respective reaction is as following. We can see in step first, the chlorine molecule is further splitted during the course of the free radical or catalytic process. In this reaction, the FeCl3 work as a catalyst to proceed a radical. So FeCl4 minus ion and chloronium ion is formed during the heterogeneous catalysis process. And the second step, the benzene ring is leave the electrons and the chloronium ion get located at the different kind of position through the resonance stabilized carbocations. This process is slow and this process is a rate determining step. In the third step, the sigma complex is formed during the course of the reaction because we have a rate determining step. So here a transition state is occurred during the reaction, and there a complex is formed. The complex is known as the sigma complex because sigma bond is formed during the reaction, and uh, this sigma complex is react with this particular catalyst in the fast because this complex is very reactive and less stable. Sorry. So we get fluorobenzene. Thank you.